What's up, guys? Welcome back to another hip video on this channel. In my last video, we talked about the disc and washer method, and we're back again with another banger. We're talking about the shell method. Be sure to like, subscribe, and buy merch. Who wants to read this one? Matthew, you look like you want to read. Start at in the last.
In the last two sections, we learned how to find the volume of a solid that is generated by revolving a region around a line using the disc and washer methods. Today we will look at an alternative method for finding the volume of a solid of revolution called the shell method. This method is called the shell method because it uses cylindrical shells instead of cylindrical slices like the disc and washer method. The shell method is not a required topic in the study of AP calculus, but knowing it can make the process of finding volume easier in some cases.
All right, fantastic. So, disc and washer, it has to be what? Perpendicular, exactly. All right, and then in the shell method, it has to be what? Pair of shell. All right, so let's look at the equations of this. And so if it's a horizontal axis, we are now in terms of what? Y. All right, because we're revolving around this way, we have to be parallel to it. If it's a vertical axis, so when we're revolving around like a y-axis, it has to be in terms of x. Now, this is the way I think of it. I think of it as like the integral with a 2 pi RH. That's really how I think of it. And so, what is this 2 pi r? It's a circumference. It's a circumference. Because on our disc and washer method, we always did pi r squared, right? Okay, because that's the area of the circle. Now we're actually doing the circumference times the height. Okay, that's really what's happening behind the scenes. Okay, and so we're going to have 2 pi out front instead of pi because it's going to be 2 pi r. It's the circumference of our circle. And then our radius is this distance away from our axis of revolution. And then our height is the function heights of that. All right, and so that's kind of how we're going to be working with it. All right, let's move. Here we go. Example 1. Matthew, would you like to pick a reader?
Krisha.
Find the volume of the solid generated by revolving the region bounded by the graphs of y equals 0, x equals 0, x equals 1, and y equals x squared plus 1 about the y-axis.
About the y-axis. All right. So this is kind of how our graph would look. However, if I were to do this in disc and washer method, how many times would I have to use my integral? I'd have to use it twice. All right. However, in our shell method, we can actually do this in one shot. All right. And so this is actually really cool. And it's already in terms of what? X, and we're revolving around a y, exactly. And so now I'd have a 2 pi out front, and my integral are going to be in terms of x. Even though I'm going around a y-axis, it's in terms of x. And so my integral is going to go from 0 to 1. And then I need my radius. And so my radius is like going out this much, and this much, and this much. And so that's actually our variable. And so our radius here is just x. Okay? And so that's how far out it would go. And then our height of this function, so this top minus bottom, would be what? The function of x squared plus 1, and then with respect to x. And so we end up with 3/2 pi. All right, beautiful.
Let R be the region bounded by the graphs of y equals 1 over x prime. Wait, it's coming. Y equals 0, x equals 1, and x equals 4. Find the volume of the solid generated by revolving region R around the y-axis.
All right, again, if we were to actually solve this one using disc and washer method, or actually in this case washer method, we would again have to have like 2 integrals. All right, and this one we don't need to. We can just do it all in one shot. All right, and so now my integral would go from what to what? Not 0 to 4, but what? 1 to 4. All right, it'd be 1 to 4. And then I have a 2 pi out front. And then what's my radius again? It's just x. It's just x. And so my radius is just x. And then what's the height of this function? 1 over x is the height of the function. And so now that's how I set it up with shell method. It's a lot quicker than if I were to have to put this thing in terms of y. End up with a volume of 6 pi. All right.
The region in the first quadrant is enclosed by the graphs of y equals e to the x, x equals 1, and the coordinate axes. Sketch a graph and find the volume of the solid generated when this region is revolved around the y-axis.
All right, beautiful. So again, we're revolving around a what? A y-axis, but this is in terms of x. And so again, if I were to actually do this, if like disk and washer method, I would again have to have how many integrals? 2. So that's the reason why I don't want to. Even though we could on this one, I don't want to. And so now we got a 2 pi chilling out front. And then what would my integral go from? 0 to 1. And then what's my radius? It's just x. And then my height is just what? E to the x. And so now we're going to put that into our handy dandy calculator. And so we end up with 2 pi. All right.
R be the region bounded by the graph of y equals x squared plus 4, y equals a, and x equals 0. Find the volume of the solid generated by the region R around the y-axis using the disk method.
All right, so this one's making you use the disk method, even though we don't always have to. All right, and so it's revolving around the what? The y-axis. If I'm going to use the disk method, what do I need to put it in terms of? Y. And so we need to solve for x, and so x is equal to what? The square root of y minus 4. All right, and so now when we do this, it's now in terms of what? Y. And so now my integral would be from what to what? 4 to 8. With a what out front? A pi. And then what's my radius? It's the square root of y minus 4, and I'm doing what to it? I'm squaring it. All right, and so now we're going to put that into our calculator. And so we end up with 8 pi.
Find the volume of the solid generated by revolving region R around the y-axis using the shell method.
All right, so we're going around a y-axis, but now we're still doing shell method. So what are we in terms of if I'm going around a y when I use shell? I'm using in terms of x. Is everybody following me on this? So right now I have x squared plus 4 as my function, which is awesome. However, I need to know the x value of that intersection. And so how would we solve for that x value of that intersection? We set them equal. So now we have like 8 is equal to this x squared plus 4. And so then we end up getting x is equal to what? 2. Okay? And so now I'm ready to go. So now I have my integral from what to what? 0 to 2 with a what out front this time? A 2 pi. And so what's my radius going to be? X. And now my height, let's make sure we do our top minus bottom. So now what's my height of this function? 8 minus the quantity of x squared plus 4 and then dx. All right, and so now we're going to put that into our handy dandy calculator. All right, and so we end up with 8 pi. How about that? That's crazy. All right, I was crazy once. All right, example 5.
Find the volume of the solid generated by revolving the region bounded by the graphs of y equals 1, y equals x cubed plus x plus 1, and x equals 1 about the line x equals 2.
All right, this one is such a necessity for shell method, and this is the way I'm going to assess you as well. Why do I say this is a necessity? For the other ones we could have done in disk or washer. However, this one has to be a shell. Why does this one have to be a shell? I can't solve for x. Exactly. All right, so we actually have to use shell in this one because this does not actually solve for x. Is everybody following me on this? All right, cool. And so I have bounded by y equals 1. And I also have x equals 1 I'm bounded by. And the revolving along the lines x equals 2. So when I'm revolving around x equals 2, that's a what axis? It's a y axis. All right, does everybody follow that? So now I have an integral, and what does it go from? It's in terms of x, so what does it go from? 0 to 1, exactly. And so I'm using shell method, so I have a 2 pi out front. Now, my radius is slightly different, but it's the same kind of concepts as what we've done. It's not just x, because I'm not revolving around a y, but it's always my right minus my left. And so what is my right? 2. And then what's my left? X, exactly. And so my radius is actually 2 minus x. And then my height is always top minus bottom. And so my top is what? That function, this x cubed plus x plus 1. And then minus the bottom, which happens to be what? 1. And so that's how I set up for that shell method. Now, I personally would cancel out the 1s. That goes bye-bye. All right, and so we end up with 29/15 pi. There you go.
Let R be the region bounded by the graphs y equals square root x, y equals 2, and x equals 0. A. Find the volume of the solid generated by revolving R on the x-axis.
All right, so this is an x-axis. Now, this one doesn't tell you which way to go, and so we can pick whichever way we want. However, I do think that there are easier methods on some of them than others. So if we're revolving around an x-axis, what's the easiest method here? I would say washer. I would say washer method, exactly. And so I'm going to have my big radius, I'm going to have my small radius, and it's already in terms of x, so we might as well just use it. So we're going to use washer method. And so how do we find my integral here? I would have an integral from what to what? What do we actually need to solve for? The intersections, right? So we're going to set 2 equal to the square root x, and so x is equal to what? 4. And so now my bounds would be what? 0 to 4. With a what out front? A pi. Now I need my big radius. So what's my big radius? 2. And I'm going to square it minus the little radius. So what's my little radius? Square root x. And so then I'm going to do what? Square it with respect to x.
Find the volume of the solid generated by revolving R on the y-axis.
All right, so when we're revolving around the y-axis, this one I could go either way. I can go either way on this one. So this one would not be a bad one to do, like a disk method. However, that involves me to solve for what? I have to solve for x. I have to put it in terms of y. That's not a terrible method on this one. However, I'm going to use shell because we're doing shell method. All right, so I'm going to keep it in terms of x. So now I would have from what to what? 0 to 4 with a what out front? With a 2 pi out front. And then what's my radius? It's just x. And then what's my height? Again, you have to remember top minus bottom. So what's my height? 2 minus square root x dx. All right? And so that would be a method that we would use for the shell method. You know what? I kind of want to do the other way too. So if I were to actually put this in terms of y, we'd end up having x is equal to what? Y squared. And so then if I did it that way, I would have the integral from 0 to what? 2 with a pi chilling out front. And then what would be my radius? Y squared. And what do I want to do with it? Square it with respect to y. And those are synonymous with each other. All right, cool. We're moving.
Wait, what method was that one? This?
Of a solid generated by revolving R on the line y equals 3.
All right, so now we're revolving around y equals 3. And so what kind of axis is that? It's an x-axis. So there are other ways to Tampa. However, I would personally use what? Washer. I would use washer on this, okay? And so now my integral would go from what? 0 to 4 with a pi out front. Now, what is my big radius? Again, let's always remember top minus bottom. So what's my big radius? 3 minus the square root of x. And what am I doing with that? I'm squaring it. Minus, what's my little radius? 3 minus 2, aka 1 dx. All right. And so then we could just put that into our calculator. All right, let's look at part D. That's you, Socks.
Find the volume of a solid generated by revolving R on the line x equals -1.
All right, so now we're revolving this around x equals -1, which is a vertical axis, aka kind of like a y-axis. All right, so could you use washer method on this? Yes, but we'd have to change it in terms of y. It's possible, but I'm going to use shell method because this is a shell method lesson. All right, and so I'm going to have my integral from what to what? 0 to 4 with a what out front? A 2 pi, because parashell. And so then what's my radius? This is the tricky part. It would be what? X minus -1, which is really x what? Plus 1. That's my radius. And then my height is this top minus bottom. So my height would be what? 2 minus square root x dx.
Thank you, Jordy, so much for watching, and we'll see you in the next video. Shout out to the birthday girl, Amaya Hutton, and make sure to subscribe to the Patreon and buy the Mu Alpha Theta merch. We'll see you on the new Galileo channel in the next one. Goodbye.